Pre-Calculus Chapter 2, Lesson 3, going to look at some examples where we describe n behavior using limit notation. So we're revisiting limit notation, and again, as we have listed over here, the 4 examples, either as the x values go towards negative infinity, the y values are either going to be going toward positive infinity or negative infinity. And then these two where the limit is as the x values approach positive infinity, again the y values will be either going towards positive infinity or negative infinity. Now the way I like to remember this, remember we have the 2 scenarios. If it's an odd, all of the n behaviors are going to look the same, and all I do is remember what a cubic looks like, because all odd n behaviors are going to look exactly like a cubic. So this is a cubic, so as you go towards negative infinity, the y values are going towards negative infinity, and as you go towards positive infinity, the y values are going to positive infinity. The inverse of that, or the reflection of that, if the term is negative, it just flips over the x-axis, so it would look like this. And they're all going to look the same, so really all we have to do is remember what the cubic looks like, and all odd functions will have the same n behavior, or all odd power functions, excuse me, be more clear about that. The other scenario is if the powers are even, and all I do is remember what a quadratic looks like, because that's an even power. And again, if the coefficient is positive, they'll both go up. If the coefficient is negative, it's a reflection, so they'll both go down. So really there's only 2 functions that you should remember. The cubic function, that will take care of all your odd functions, odd power functions, and your quadratic will take care of all your even powered functions. So if you can remember those, you have all of the possible n behaviors. So I'm going to do a few examples. I'll do 2 examples, one where it's already in standard form and one where it's in factored form. And if that's enough examples for you, then you don't have to watch the rest. Just watch as many as you need. Alright, so our first example. Our first example is we have one that's in factored form. It's not in standard form. And again, the only thing I need to know is I need to know what the power of the function is, and I need to know whether the leading term is positive or negative, and that will give me the n behavior. Now, because this isn't in standard form, I need to know what the power is. And the power is simply going to be the addition of these exponents, because this is x to the cube once I multiply all these together. So this is going to be x cubed, and that's going to be multiplied by this 2x. And so when I multiply all those together, this is going to be a 4th power. So all I really need to do is to look at the exponents and add them together if it's in factored form. So this is going to be a 4th powered polynomial. Because it's even, I know it's going to be either looking like a quadratic where both are going up, or a quadratic where both are going, where both are going down. Okay, so that gives me, that I get from the power. What I need to know now is the leading coefficient positive or negative? Positive will go up, negative will go down. Well, this term is positive. When I raise it to the first power, is still positive. This term is positive, and when I cube it, it's still going to be positive. And then those 2 positives are going to be multiplied together, so the leading term is going to be positive, so the n behavior is going to look like this right here. So now that I know what the n behavior is going to look like, then all I have to do is put it in limit notation. So as the x values go towards negative infinity, the y values are going towards positive infinity, so that would be scenario A over here. And as the x values go towards positive infinity, the y values are also going towards positive infinity. That's option C here. So the n behavior is going to be described in limit notation using A and C here. That's how you would write it on your homework. Okay, so again, you'll have to write that on your homework. I already have them written out as multiple choice options here, but just remember, you'll need to write those out on your homework. Okay, so let's do another example where this time it's in standard form. Okay, in this scenario, the leading coefficient, it's already in standard form, so the power is a 4th power. So again, I know it's going to go up and up like a quadratic, or it's going to go down and down like a reflected quadratic. Because the leading coefficient is a negative, I know it's going to be this scenario here, so now I know what the n behavior is going to look like. I just write it in limit notation. So as I go towards negative infinity, the y values are also going towards negative infinity. That's option B. And as I go towards positive infinity, the y values are also going towards negative infinity, so that's option D. So in this case, those would be the end behavior described in limit notation. Okay, again, those would be the two types of scenarios you're going to have, one where it's already in standard form, one where it's in factored form. I'm going to do 3 or 4 more examples if you want to watch. If not, you think you have it, just go ahead and shut off the video and go ahead and tackle your assignment. But I will do about 3 or 4 more for you. In our next scenario, this one is in standard form, so again I need to know the power. It's a third degree, so I know it's going to look like a cubic. So you remember a cubic goes like this, but again I'm only interested in the end behavior, so I know that it's going to go down over here and up over here. This middle part doesn't really matter. So it's either going to be doing that if it's positive, if the leading coefficient, or the reflection of that if it's negative. Because the leading coefficient is negative, it's going to be the second option that I wrote, so my end behaviors are going to look like this. So all I need to do now is put that in limit notation. So as I go towards negative infinity, the y values are going towards positive infinity, so that's option A here. And then as I go towards positive infinity, the y values are going towards negative infinity, so that would be option D. So the two limit notations for this would be A and D. Okay, a couple more examples if you want to keep watching. So in this example we have another polynomial that's in factored form. So to determine the power, I simply add up all these exponents. So this is a 2 plus 1 plus 1, so 4. So this is a fourth powered scenario. So they're either going to go up and up like a quadratic, or they're going to go down and down like a reflected quadratic. Again, this term is going to be even after I square it. This is going to be even, positive. This is going to be positive. This is going to be positive. All of those multiplied together are going to give me a positive leading coefficient. So it's going to be this scenario here. So then I just need to write it in limit notation. So as I go towards negative infinity, these y values are going towards positive. That's scenario A. And as I go towards positive infinity, the y values are going towards positive infinity. That's option C. So my end behavior is going to be described in limit notation as if I was doing A and C here. I think I have one more example if you need to watch. So in this example, we're already in standard form, so it's easy to tell that the power is a fourth degree. So again, that's going to be an even power, so it's going to be either a quadratic that opens up or a quadratic that opens down. The leading coefficient is positive, so it's going to open up, so my scenario is going to be this case right here. So in limit notation, again, as the x values go towards negative infinity, the y values go towards positive infinity, so that's option A. And this way, as the x values go towards positive infinity, the y values go towards positive infinity as well. That would be option C. So I hope those were helpful for you. And again, if you need to watch the video again, go ahead. If you think you have it, then we'll see you when we talk in the next video when we talk about the zeros and how we can use those to help us continue to get and determine what the shape of these polynomial functions is going to look like.